Now coming to question number 15. Ablation rates for 3 elements in cosmic dust by dust source. We have a table over here. 3 elements are iron, potassium and sodium, and then we have SPC, AST, HTC and OCC, and some percentage is given. So let's read the question to find out what that is. Earth's atmosphere is bombarded by cosmic dust originating from several sources: short period comets, SPCs, particles from asteroid belt, ASTs, Halley-type comets, HTCs, and Oort cloud comets, OCCs. Some of the dust's material vaporizes in the atmosphere in a process called ablation, and the faster the particles move, the higher the rate of ablation. Astrophysicist Juan Diego, Carrillo-Sánchez led a team that calculated average ablation rates for elements in the dust such as iron and potassium, and showed that material in slower moving SPC or AST dust. So we know that SPC and AST dust are slower moving, has a lower rate than the same material in faster moving HTC or OCC dust. So I just underline that. For example, whereas the average ablation rate for iron from AST dust is 28%, the average for blank. So here the keyword here, whereas, that means we are comparing some slower thing to a faster thing, looks like, because here you see AST is slower, they are saying. So something with HTC or OCC we might have to select because of the word whereas, because we are comparing two things. So which choice most effectively uses data from the table to complete the example? Is it A, iron from SPC dust is 20%, sodium from OCC dust is 100%, C, iron from HTC dust is 90%, or D, sodium from AST dust is 75%. So which do you think is correct? So if you said C, that is the best answer, because it effectively completes the example regarding the ablation rate of iron. So what is iron with relation to HTC? 90%. I think that's iron from HTC dust is 90%. That's what it says. The table shows the ablation rates for 3 elements: iron, potassium and sodium, as you know, these 3 elements found in cosmic dust that comes from one of 4 sources. And then the text says that the ablation rate for a given element in slower moving SPC or AST dust was lower than the ablation rate for that same element in faster moving HTC or OCC. So what is ablation? That has been mentioned. Ablation is like, you know, the thing is the dust materials vaporizing. Okay, so some are fast and some are slow. So SPC or AST dust was lower than the ablation rate for the same element in faster moving HTC or OCC dust. The text then presents the first part of an example of this pattern, describing the ablation rate of 28%. What it is talking about? 28% of AST dust. The information that iron from HTC dust had an ablation rate of 90% is therefore the most effective way to complete this example, because the comparison of a relatively low ablation rate for iron in a slower moving AST dust with a relatively high ablation rate for iron in a faster moving HTC dust illustrates the tendency of ablation rates for a given element to be lower in slower moving dust than in faster moving dust. So if we are comparing both same elements, like for example here iron from AST, which is slow, is 28%, and then if we directly compare it to faster moving ablation rate 90% from HTC, so for the same element iron we are able to give a comparison between a faster moving and a slower moving. Okay, so important thing is to maintain the same this one element also, and then because of the word whereas we have to compare one slower one to the faster one. Okay, and so why A is incorrect? Because iron from SPC dust is 20%, it says. That is there, but it is correct from the table, but we are comparing both slow moving in that case. SPC is also slow and AST is also slow. Yes, the text indicates that SPC dust, like AST dust, moves relatively slow. A comparison of ablation rate of iron from 2 slower moving dust could not be an example of the difference between ablation rates in slower moving dust and faster moving dust, which is the pattern that the example is supposed to illustrate. And B is incorrect because The example in the text is supposed to illustrate the difference in ablation rates of the same element from slower moving to faster moving. Here, instead of iron, we have sodium. And the first part of the example provides data about the ablation rate of iron, which means the second part of the example should also have the ablation rate of iron, not the ablation rate of sodium. So we cannot take that. Choice D is incorrect because the example in the text is supposed to illustrate the difference in ablation rates of the same element. Again, the same reason we are eliminating both B and D, because in that we are having sodium, not iron. So choice D is incorrect because the example in the text is supposed to illustrate the difference in ablation rates of the same element from slow moving dust and faster moving dust, and the first part of the example provides data about the ablation rate of iron, which means the second part of the example must be about the ablation rate of iron, not the ablation rate of sodium. And and here it's wrong in two accounts, because then sodium from AST dust they have mentioned, that is again slow moving and not even the same element. Any ablation rate from AST dust would be ineffective in this example, since AST dust is referred in the first part of the example, and thus additional data focused on AST dust would not illustrate the variation across dust types. So I hope that's clear.